Alright, welcome to this video, and we have been asked to limit this function root of x plus 4 all minus 2 divided by x, and we have been asked to limit x to 0 and see what happens. And like we explained in the beginning, whenever we limit a function, our goal is to see the behavior of that function as the function approaches that value. As x approaches 0, what is the behavior of root of x plus 4 minus 2 divided by x? We don't really care what happens when x arrives at the value 0. We don't care what the function does at that point. What we care about here is what the function does as it approaches the value 0. So as we do always, let us test our value 0 and see what the value 0 gives us. So the limit as x goes to 0 of x plus 4 minus 2 all over x, this is in all roots, is equal to all roots of 0 plus 4 minus 2 dividing 0. So we have this to be equal to all root of 4 minus 2 all over 0, and this becomes root of 4 is 2 minus 2 is 0 all over 0. So here we got 0 all over 0, which is the indeterminate form. So we have two methods here. We can either use the L'Hopital's rule or the sort form in the form of rationalization. So first of all, let us try to rationalize this function. Now you notice that this function, the numerator of this function is in the form of, like I always do, the form of root of a minus b. And when you have a sort in this form, it can be written in the form of its conjugate. And the conjugate of this man you are seeing here is just writing the same man but in reverse sign. So according to this question, we will be rationalizing. So rationalize using the conjugate of the numerator. And this is the numerator. And what is the conjugate of this man? The conjugate is equal to root of x plus 4 all plus 2 then all over x. So what we'll be doing is this: we'll be multiplying the top and the bottom of this function by this expression here. So let's do that. So we have the limit as x goes to 0 of the function x plus 4 minus 2 all over x, all in root, is equal to this x plus 4 minus 2 all over x. We are multiplying the top and the bottom by the conjugate of this, which is this man here. The conjugate of this is this man here without the x. Pardon me. So we are doing that. So multiplying by x plus 4 plus 2. The same thing here, x plus 4 plus 2. X plus 4 plus 2. So we have this to be now when you check these two expressions, you notice that the numerator here is just difference of 2 squared. That is, they had the same expression but in reverse sign. So when you have something like that, you should know it is called difference of 2 squared. And to multiply out difference of 2 squared, you can do it whatever way you like. You can do the first and the first and the last, last and the first, last and the last. Any how you want you can do. But when you are dealing with difference of 2 square, to make your life easier, you just have to multiply out the first and the first, the first and the first, the last and the last, the first and the first, the last and the last. So let's do that. Now when you multiply the same root, the answer is just what you have in that root. Square root of 4 by square root of 4 is square root of 16, but the answer is still 4. Square root of 5 times square root of 5 is square root of 25, but the answer is still 5, which means that square root of this man by this man, the answer is still this man. So this time it will give us x plus 4. Negative 2 by positive 2 will give us negative 4 all over negative 4 all over this multiplied by this. So we have x all multiplied by root of x plus 4 plus 2. X plus 4 plus 2. And this gives us 4 minus 4 is 0. So we have x left here. So x dividing all we have here. Root of x plus 4 plus 2. X plus 4 plus 2. So the limit as x tends to 0 of the function x plus 4 minus 2 all over x is equal to, you know that we can just take away x here and x here. So we have 1 over root of x plus 4 then plus 2. Then at this point we can apply our limit. At x equals 0. So at x equals 0, we have the limit of this function to be 1 over the root of 0 plus 4 plus 2, and that will give us 1 divide the root of 4 is 2. 2 plus 2 is simply 4. So the limit of this function as the function goes to 0, this function root of x plus 4 minus 2 all over x is equal to 1 over 4. And that is it using the method of rationalization. Now let us apply L'Hopital's rule to this function and see what L'Hopital's rule gives us. Now using L'Hopital's rule. L'Hopital's rule that says that we should apply derivative to each component part of the equation. So we have dx on the limit as x goes to 0 of the function all root of x plus 4 minus 2 all over x is equal to derivative on all root of x plus 4 minus 2 over derivative on x. So we have dx of the limit as x goes to 0 of this function x plus 4 minus 2 over x is equal to, now we know that if we differentiate 2 will go to 0. So this negative 2 go to 0. But this root of x plus 4 is kind of tricky. So let us bring it out and differentiate that. So let's assume that y is equal to all root of x plus 4. And we know that this can be written again in the form of x plus 4 all to the power of 1 all over 2. This implies this, and we are assuming that this is a variable to a constant issue. When we have that, to differentiate that, all we have to do is just bring it down, right? So we have the y all over the x equals to this 2 comes back down to be this, and we have this left here, x plus 4. If we differentiate what we have inside, you have 1 multiplied by 1, and this 2 goes to half minus 1, so we have 1 all over 2 into x plus 4 negative half, and this will imply negative half stands for, this negative half stands for 1 all over root of x plus 4. So the y dx of that function is equal to 1 all over 2 root of x plus 4. Let's bring it here. So the limit d dx of the limit as x goes to 0 of the function root of x plus 4 minus 2 over x is equal to, for this part here, we got the value to be 1 all over 2 root of x plus 4. This man goes to, the 2 here goes to 0, all over 1, this one goes to 1. So everything still remains what we have here. So at this point, we can apply limit to our function, and that limit at 0, at x equals 0, we have 1 dividing all roots, so 2 into 0 plus 4, which will give us 1 all over 2 into square root of 4, and that will be 1 dividing 2 times 2 equals 1 over 4. So we can conclude that the limit as x goes to 0, of the function x plus 4 minus 2 over x, using the L'Hopital's rule as well, gave us 1 over 4. Thank you as you stay this long with us. See you in the next video.